Hi everybody. So today's lesson is following on from what we learned the last lesson, which was about standing waves in strings and pipes. And we're just carrying on in the same vein, which has to do with musical instruments. So the one that I have here is a guitar. And we're going to talk about two things. One is about the loudness and the other one's about pitch. So what do you mean by loudness? So I can play something softly or I can play something like really loudly. So loudness has to do with amplitude. So if it is a soft sound, the amplitude of vibration is really small. But if it's a loud sound, then the amplitude is much larger. And the loudness also is an indication of the energy, because the higher the amplitude, the more the energy. So loudness depends on the amplitude. Okay. Now the other term that we need to know is the word pitch. So that's a note. So can you see, like, the lower notes have a lower pitch, the higher notes have a higher pitch. Okay, so what does pitch depend on? So pitch depends on frequency. So higher the pitch, higher the frequency. What is frequency? How quickly something vibrates back and forth in 1 second. So that number of vibrations per second is the frequency. So all notes have a frequency. So today we're just going to look at how can we change the pitch of a note. How can you get higher notes, lower notes in a musical instrument? So those of you who are familiar with it already know. But then we just need to justify why these things happen. And the way we justify this is by thinking of the formula for waves, which is V equals F lambda. So what are we trying to do? We're trying to change the frequency. So if you're changing the frequency, we need to either change the speed with which the wave travels, so long as the length of the string or the pipe is the same, that means wavelength's the same, or we are keeping the speed the same but changing the wavelength. So there are different ways of doing this. So let's look at changing the speed to get a higher frequency. Now, one way we can do that, if you look at the guitar string, I don't know if you can see it, these strings are all different thicknesses. So this one is a thicker string, the note is quite low, whereas that one's a thinner string where the note is high. And the reason is sound travels slower through a thicker string compared to a thinner string. Okay, so if the speed of sound is less, but the length of the string is the same, so they're all the same length, so the wavelength's the same, it goes faster. So if V increases, frequency will increase. So the faster sound travels through a particular string, the higher the pitch. And that's why you get a higher note on a thinner string, because sound goes faster through it. What's the same? The wavelength's the same. Why is the wavelength the same? Because the length of the string is the same. Okay, so that's one way. By changing what we call the mass per meter, that means the mass of a heavier string is more for 1 meter of it compared to a lighter string. The other thing that you can do is, you see these things over here, this can be tightened or loosened by turning this, and what happens is you're tightening or loosening the strings, and that will have an effect on the note that's produced, the pitch of the note. In other words, it's going to have an effect on the frequency. So when you're tightening or loosening a string, what you're effectively doing is changing the tension in the string. So how does changing the tension affect the frequency of a note? Now, sound travels faster in a tighter string. So the tighter it is, the higher the pitch, because more quickly sound travels. Okay, and what's the same? The length of the string hasn't changed, it's only become tighter, so the wavelength stays the same. So in all your answers, you must always say, what is it that stays the same, what's it that changes, and the effect it's had on frequency. Okay, and then the last one is changing the length. So you get a note. Oops, let's do a little one here. But if I put my finger here, so you get a different note because I've effectively changed the length of the string. So a shorter string, so if the wavelength is less but the speed's the same, what's going to happen is that has to become a higher number in order that the product is the same. Okay, so shorter strings is the shorter wavelength, but this speed's the same, so the frequency is going to be higher. And in SP3, I do have a pan flute, which is a flute, a set of flutes with little, it's a little bamboo one, but they have little ones and big ones all in one. So when I blow through the little one, the wavelength is shorter, the wave travels at the same speed, you get a note of a higher pitch. Okay, so that's how you change the frequency of sound in a musical instrument. So bye for now.